Hi everyone, so let's talk about remove unknowns from end of the list. So you are given the head of the linked list, remove the unknown from the end of the list and return its head. So this question is pretty simple. You don't have to reverse and you can just traverse and then you find out the remove node and you just redirect the 3.next to 5. So this is how you actually do it. So how do you actually do it? You need to create a dummy node and dummy node point at the head. And you need a 2 pointer. One, I'm going to call left and right, and left is going to point at dummy, and right is going to point at 1, which is head. And I need to set the size for the left and right. So the size for the pointer, which means it's the space in the between, right? So since n is equal to 2, right? So I need to move 2 for the right. So this will be the size of the pointer. The left and right can have a 2 pointer, two nodes in the between. So when you have 2 pointers in the between, right, you can actually traverse. So how do you actually traverse? So you traverse left by 1 and right by 1, left by 1, right by 1, and left by 1 and right by 1 until right becomes null, right? And you can actually know the left next. The left next is actually the point, the node you want to delete, right? So you can actually redirect your the left next to the left next, which is, I'm gonna call it star. So this is how you actually do it, and then you return a dummy next, which is 1, right? This is become dummy next. I'm gonna call it x. Okay, so let's just code it, and I'm gonna create a dummy node. Dummy equal to new list node, and I can initialize to -1, and I need to create a left equal to dummy, and also list node r equal to head. So I need to traverse, right? Traverse will become for loop, and actually I don't need to for. I can use while loop, right? So while n greater than 0, and also right is not equal to null. So n minus minus for sure, right? But before we minus, we need to say right next. And also we need to point my dummy to the left, right? So dummy next will become head. All right. So this is how you actually set the size in the between, right? So left will be a dummy and right will become 3. So you need to traverse that 1 by 1, right? So while r is not equal to null, and r equal to r.next, l equal to l.next, and then you will hit at this point, right? So they just help you to go to the end of the, okay. So r will hit, r will become null. So we break out the while loop. So when we break out the while loop, we can actually redirect the 3, right? So l.next is equal to l.next. And this is how you actually redirect the linked list. We don't care about we don't care about this node.next. We can actually just care about this node.next. Because when we redirect the 3.next, right, we can actually avoid the 4. And you can actually just return. What do you actually need to return? Return dummy.next. And this will be your solution. And let's just run it and see what happens. And as simple as it is, right? So let's just optimize this solution. So we can actually just delete the list node, and then we can just use a comma right here, and we can also delete the list node and which is a comma right here, and let's just make it more readable, and also set a size in between. So this is how I actually code it, so make it more efficient to look. And let's just run again to see if I have any error or not. So let's just run a code, submit. So this shouldn't be a problem, right? So let's talk about time and space. So for the time, you need to traverse every single node, right? It doesn't matter like you traverse the right pointer first or left pointer first. You need to traverse, so which is all of them, right? So space complexity is constant. You don't actually create a number of space for the linked list. So the space complexity will be constant, all of 1, in my opinion, and time will be all of n. And that will be a solution. And I wish you luck.